to everyone and welcome to our cloud coaching session. Today we talk about observability in OCI and Kubernetes OKE monitoring. My name is Violeta. I'm part of the digital customer experience team in Oracle EMEA. Today I'm happy to announce that we are joined by the OCI Observability and Monitoring team, and we have Karthik and Erika presenting for you today and demoing, of course. And we have as well the application development team in Oracle EMEA, and we have Alberto here that who will show some cool stuff in the demo on the app dev side. That was all on my side. Karthik, over to you.
Thanks, Violeta.
You're welcome.
Hi, everyone. This is Karthik. I'm working as a cloud specialist focusing on observability and automation here in Oracle. So today we are going to see on observability for Kubernetes, and we'll focus on OKE, Oracle Kubernetes Engine today, but this applies for other Kubernetes as well. So let me start sharing my screen. So what we are going to see today is only focusing on Kubernetes monitoring, but I want to highlight what are the other services we have. These are the portfolio of observability services in Oracle Cloud, starting from logging analytics, and then you have this operation insights, database management, and application performance monitoring. So what you have for logging analytics, it can collect logs from any of the systems or files from your operating system. It can collect from syslog listener. Sorry, one sec. Yeah. So it can collect from syslog as well. Using this logging analytics, we are going to collect the Kubernetes pod and container logs, as well as we are going to collect the metrics of pod CPU using some stateful set management agent. And Erika will be talking about application performance monitoring and how you can monitor your application which is running on Kubernetes. Okay. And what is stack monitoring is useful for you? The stack monitoring service is to monitor your infrastructure for your application. It could be your host, it could be a WebLogic, Apache, or it could be your MySQL or Oracle database as well. Okay. So, and we also have the foundational services like monitoring, service connector, and notification, which I'm not going to do deep into this session. So the next thing is I'm going to focus is on what you're going to have the architecture if you want to instrument your Kubernetes logging. Okay. This is the architecture diagram where you can collect your Kubernetes logs and metrics into the OCI logging analytics solution. Starting from the left, it's showing it could be your on-premise or third-party Kubernetes cluster. And the right-hand side is the OKE, Oracle Kubernetes Engine cluster. So how it's getting collected is we have a Fluentd agent as a daemon set. So it collects the logs and it pushes to the Oracle Logging Analytics cloud. And if you want to create an alarm for these messages, for example, error messages, exceptions, or any other events happening in your logs or metrics, you can trigger an alarm and notification as well. Okay. So this is the implementation, how it's done. And we have a stack in the Oracle console called Kubernetes monitoring stack, or you can easily install this using a Helm chart. And what I'm going to show you today is a dashboard as a customized build dashboard. When you use this solution, you will get 4 dashboards out of the box. You can add that dashboard into your cloud tenancy. And you can customize as I have done today. Okay. So I will start showing my dashboard and I will explain you how you will be doing your Kubernetes monitoring using the solution. Okay. I'll just quickly share my Chrome browser. I hope you can see it now. Yeah.
Yep.
So this is a customized dashboard I have built for Kubernetes monitoring. And if you want this dashboard, you don't have to build it again. Okay. So you can easily export it and import it into your tenancy. Okay. So you can let me know in case if you need this, I can share this JSON after the call. So what do you see here? If you see this top, I have classified into different categories like pod, metrics, node logs, pod or node metrics, workload summary, control plane, and audit. In OKE, we also expose the control plane logs now. I will start with the control plane logs. and tell you. In on-premise server, you have the control of your API server and all the control plane components. But when you start using managed service like Kubernetes managed service like EKS, AKS, or GKE, you don't have control on your control plane of Kubernetes. Okay, but you want to see some of its logs for your debugging purpose or other reasons. Okay, so we give the Kube API server Cloud Control Manager logs for you, so you can see and troubleshoot in case if there is an issue on the API side. Okay? And we can also see the API request here in this metric. So I'm just have a widget which show the how much API server request is going, and is there any problem from the response, like is it 2xx or 5xx or other status codes can be shown. Okay, so where this is coming is like these are coming as a service log, and using the service connector, these logs are moved to logging analytics. Okay, and then if you're going before monitoring, sometimes we need to know what is happening in our Kubernetes environment. Okay, for example, I have a Kubernetes pods of 5 pods running in a namespace or called default namespace. I expect that 5 pods to be there, but someone of my team or someone deleted a pod. I want to know who deleted it, or when it deletion happened, or something related to that event. Okay, so these events are already captured in the audit logs of Oracle Cloud. So from that, we can see just a glimpse of it. So in this case, you can see here, I have a pod delete audit dashboard widget, and then showing the trend of it. What are the actions happening in Kubernetes? One thing to note here is you don't have to send all the audit logs via service connector to the logging analytics, because audit logs will be a large of information will be there. You can just use a filter and get only your Kubernetes related logs and what are the events you are interested in. In this case, I just sending only these kind of events, like if any pod deletion happen, I want to know it. If someone creates a namespace, someone deletes the namespace, I want to know it. So I'm just focusing on that events. And here you can see there is a pod which was running on mem example was deleted at 2:55 p.m. today. Okay, so I just created this namespace and deleted it before. Okay. And also you can see there are 3 things. How the color code is based on the namespace. Okay, so this pink color is having the pods of the default namespace pods, and you can see there are 3 pods, and this belongs to Nginx deployment from this name. Okay, so you can find this Nginx deployment. I have 3 replicas, so 3 pods are running. I deleted the deployment, so I can see 3 events happening for these pods. Okay, so these are important as well for auditing, so that you know in case something gone wrong or someone deleted it, you want to audit it, this will be useful for you. Okay, now coming to the Kubernetes monitoring. Okay, I just go through this dashboard or widget one by one, and then what I'm going to do is like I'm going to show you live like how an event happened, how you can see in this dashboard. Okay, and in general, if you are a Kubernetes operator, what you do is like you might use some of the IDE tools like Lens or other tools like Rancher, or you will just use kubectl command to get the information. Yeah, this is fine. Like you can run kubectl logs, you can always get the information whatever you look for in your environment, but you won't get a holistic view of it, or else you need to run multiple commands to come to a conclusion or to get the information. Okay, so let me give an example. I want to know my pod status. What I will do is like I just run kubectl get pods to know my pod status. Then I want to know my events. I will run kubectl get events command to get my events. There are some IDEs which you will find it using a click of a button, these information. But if you're using kubectl command, this is how you do it. Okay. Starting with this widget, I'm showing here like how much pods are running. Ideally, this could be green or it should be white with a 0% trend. What that means, I have 35 pods or some number of pods before running, but I see a 3% percentage of increase from the last 5 minutes or 15 minutes, whatever I have set the interval to. Okay. This shows that could be a scale up or someone is creating some things through a CICD pipeline, it's fine. If it is in green, that shows indication it's going scale up. It's okay if it is in the lower range, like 3%, 2%, but if it is like 50% or 70%, that means something is wrong, someone hacked it, they're running so many pods on your Kubernetes cluster, things like that. If it is in red, that means it is not expected pod numbers from what you see from the previous 5 minutes or 10 minutes. You can set the interval based on your requirement so that you would give the trend. And here you can see I have 2 pods pending, and it is indicated here in the red mark. I have 2 pods named failed pod 1 and failed pod 2. Okay. These are not running, and these are not running in the namespace default. And you can also see this from this widget, what are the pods are running in these namespaces. And if you see some difference here, it will change into red mark. That means if it is increasing, it will be in red mark. And as you know, this is just an indication of showing how many namespaces you have and all the other stuff. And you have to notice here, like, this is important that sometimes you don't know like what the number of name pods are running your namespaces. This will give a easy overview. And here I have 5 pods running in my default namespace, but 2 are not running. So these are the 2 pods which are not running here. Okay. And these are the just holistic view which we got. We can also got this from the IDE, but not through the kubectl in one view. Okay. And the next widget I want to focus is the error trend. Pod, whenever you launch a pod, there are some events which will happen, like it tries to start it, it tries to pull the image, and then it will launch or schedule it on a particular node. If the node is available and it doesn't have any tolerations or taints, it will be scheduled and will be successful. So I'm not focusing on successful pods because we don't care for successful running pods. We only care on having a problem error prone scheduling. Okay. So in this case, I have given an indication of what are all the pods which is having a problem and which namespace it is there. And also I have able to find which node. Let me give you an example here. That take this one. The name is a memory demo application, memory demo part, which was running in mem example and was running in the node called event source name like 10.0.81.71. It couldn't start because of some out of memory error, but it won't show those information here, but will just show the crash loop back off. Okay. And I will be able to find that from more logs, but these are the indication that you will be able to quickly see what are the pods which are not running on my Kubernetes cluster, on which namespace and on which node. With this information, you can come to the conclusion that if there is a problem on a specific pod on a node, then you will troubleshoot the node related errors or troubleshooting stuff. If it is problem on the pod on every default, every namespace on the nodes, then it's problem with the YAML file or some configuration with your pod itself. Okay. So this widget will give you a quick information about these details. Okay. And what I'm doing with this widget is to find all the Kubernetes events for each pods, because if you run kubectl get events or things, it will list you all the events in not in related to only that pod. It will give you all the events. Sometimes you want to focus only on this one. Since we have this problem for this memory demo pod, I want to know what are the events happen only for this pod. I click on this. It will take me to the events related to only to this pod. Okay. And not other pods, anything like that. So I can see that it's in the different order. Okay. It pulling the image. There is a stress tool which is running as part of the YAML file or the pod. It is pulling the image. I know it's been assigned to the pod or node. This shows that there is no problem with the node because it is assigned to it. And then image is pulled. So we have no problem with the image pulling or secrets. We don't have any problem. The container is trying to start and the pulling image is happening. But then once the pulling image is done, it's showing that there is a problem in starting the container. So now with this events of this pod, we know that we have ignored some of the errors which would all happen in common places, like this image problem. We don't have it. There is no problem with the node. Node is not done because it got scheduled. We come to the conclusion there is some problem with the container of that pod. Okay. And more debugging, we can find out like what the pod issue itself. Okay. So going back. So these are just kubelet error logs. All the kubelet information will be here. And also I have shown you this Kubernetes event records here. So I got this information here. So I also have the kubelet logs. What I have shown you is the event record. In case this is like how you do kubectl get events. You can see all the events of all the pods or services of whatever the kind you have in your Kubernetes. Okay. With this information, I was able to easily find out what are all information I would be manually doing it using kubectl command or connecting to my Kubernetes config using an IDE, because the secure in most of the things, like we suggest to use a private cluster so that it is secure. If you're having a private cluster, you need to have a bastion to connect to it, and then you need to log in and you need to close. If you have closed it, you need to initiate the bastion again, and then you need to connect it. So instead of you connecting to the Kubernetes cluster and checking via IDE or your kubectl command, we given here all the overview information which is important for troubleshooting. Okay. These are the information related to the pod related, and then we go to the node, because I show you the indication that there is no problem in the scheduling of a pod to a node. In case if you have an issue, you will be finding it here from the status, whether it's not running or running. Is there any pressure called disk pressure, memory, or what are the version you are running? This information can be found here. Okay. So I want to show you one more thing here. I want to see in the last 3 hours. Okay. The reason is like my node got scaled up before the 3 hours. Okay. Maybe I will increase it to a little more time for 4 hours. Yeah. If you see this node count, I was having 2 nodes earlier. Okay. Due to my auto scaling or manual scaling, the node increased it. For folks who are using autoscaler and node or manual scaling for your application, this is important to know, like when these nodes are auto scaling, or maybe this time you have more application load, you will get some information about that. And also, in case if this auto scaling is not happening as you expected, you can easily find it from this node count and what are the pods running on your OCI node. So this widget, using this widget, what I'm trying to convey here is, you see that I have 3 nodes, but I don't have any of the pods running in my 10.0.126.115 node. Okay. So only kube system pods are running, but I don't see any of the pods running in other example. Maybe I don't have any pods running, but there is a reason for this. I will show you, because there is a taint for this node, that no scheduled taint is there. That's why none of the pods are scheduled yet. This, I could have seen it by going to the IDE and find it, but also this widget is giving an indication that, okay, we don't see other pods in other namespaces, and that could be some problem. And if none of the pods are scheduled here, then again, it's a problem with the node. It could be down, or it could be a taint for other configuration reasons. Okay. And you can always see whether you want to find the running pods or pending and succeeded. So in this case, I have a pending pod called new in the new namespaces. This is the namespaces, and the pod name is new NS pod. And then we have seen so far the metrics which are coming from the logs and events. But we are interested in metrics as well. We are not interested only in logs. We want to know how much is my pod CPU utilization, how much is my node utilization, and what are the pods or the count of pods on my node. Okay, I can use this widget or use this metrics. How these are coming? These are coming from CAdvisor metrics. You can see in your metrics explorer, there will be a namespace called management agent Kubernetes. Namespace will get created once you install this solution. Okay, and you can create the widget and metrics as you wish. In this case, I just created for pod CPU usage and node memory usage. And this looks clumsy, but I'm interested in finding one of the pod usage. I can filter it here, okay, saying that OCI ONM, this one. So this is the pod which is running as a stateful set pod. I want to know the pod utilization of it. Okay, so I can easily filter it by the no pod. I can also add another pod if I want to find it. In this case, I want to know, is there any node exported details? I can easily filter it and see it in this widget. Okay. So I cancel this one. This is how easy you can filter it using within the widget itself. Okay. You could have run kubectl top pod or kubectl namespace, or if you're using, I've seen from the poll that most of you have used Prometheus and Grafana. It's a nice tool, but I'll come back later like what's the difference this tool offers compared to the open source tool as well. And you can see this matrix of node and node memory utilization and all the node details. And the last widget is showing you what are the count of pods running on a node. Okay, and if there is an increase, that means more pods are assigned to that node compared to the other nodes. In general, we want all of our pods to be evenly scheduled on other nodes unless you have a specific requirement that this pod has to be scheduled on that node. If you have a deployment of 3 replicas, you want each replica to be scheduled on each node. In case if that scheduling or event distribution is not happening, this will give an indication and you can see why it has not happened. Is that node doesn't have enough memory, that's why that pod is scheduling on another node, and you can find such information. Okay. And this is just a summary, the workload summary of knowing like whether your deployment desired and the expected ready state is proper or information will be here. Okay. So in this case, you can take an example of metric server. This is one expected, and then I have one schedule as well. Okay, so you can see ready how many replicas are available. This gives the information for stateful set, daemon set, jobs. You can also add cron jobs and other widgets if you want. But like I said, I have customized it for my requirement. You can customize it as ever you want for your needs. Okay, so I will stop sharing and I will come back to this widget, showing you a live demo like how this is coming up in the widget. Okay, I want to show you my Kubernetes environment so that I want to show you that these are live and it's not like pre-built one. Okay, I want to create a deployment first. Okay, I hope you can see my open lens. I just created a deployment.
Yeah, we can see that.
Thank you, Tom. So I just created a deployment. In production or in normal environment, we don't do like kubectl. You would be using your CICD pipeline and other things. I'm just, for the sake of the demo, I'm doing it in kubectl manually. Okay, but this will be in production. You would be doing it via your CICD pipeline or a Helm chart. And I want to create some more failure pod. Okay, say failure pod 3, and the image doesn't exist, so that's why it's a failure. And I also want to apply another pod. One sec. Which has some stress tool installed there. Okay. And I also want to create a namespace. Okay. I call it demo ccns. Okay. So these are the things I did it. And maybe I want to delete one of the pod called fail2 as well. The previous pod I want to delete it. You can see here that these 3 pods are in pending status. Okay, but if you see the other one, I will show you here. I will delete this pod. Delete pivo failed pivo 1. I will delete that pod. Yeah, so we have done some action here, and now we want to see how we get an alarm as well. Okay, because it's not always that we see a dashboard or we see this UI. Whenever something happens, we want to get alarm. Okay, I have deleted a pod and I wanted some email or alarm to be triggered for me. Okay, I have already set up an alarm based on this event from the audit log, and I get an alarm for this delete pod events. And also we have created these. I will show in the dashboard like whether these are coming up live. Okay. Give me one sec. So now we have done some action in the Kubernetes. Let's see whether we are seeing this in here as well. Okay. And let me start with the pod. So I have explained you these widgets, but you can create your own widgets. Like I said, all the logs information is there, and how you want to get the information, you can easily get it in a widget based. And I haven't explained about these pod logs. These are important for application error and troubleshooting because we are only focusing on Kubernetes related metrics and monitoring, but sometimes we also need to know our application logs. So these are the pod, and if you click on it, you will be going into the specific application. For example, log generator is one application which generates logs. If I want to see what's the problem in it, I can easily find it. Okay. And we also have other machine learning capabilities, which is already available in YouTube. So I'm not focusing on that feature now. Okay. And let's see here, how many of events are happening or not. Okay? So you see this one, I created a fail pod 3, and you see this event happened now. The names is failed pod 3 here in the object name, and this has been in the node 10.81, and it is trying saying fail to pull image test file because that image is a wrong image. So this is how you see in near real time that you have a problem or you did something, you can see it in this dashboard immediately. Okay, and you also see this in the events as well. Image pull back off, and if this pods come up, this will be here as well. Okay, and I want to go to the audits and see if my pod delete event is coming to my dashboard. Okay, and let me check here. Yeah, I deleted my failed pod one. I can see this, and I want to see like who deleted it. I can also find that username here. Okay, if I drill down more into this, I'll be knowing that who deleted it with my username and all those things. Since I don't want to show that, I'm going back because I don't want to show my user ID here, but you will be able to know who the user has deleted it manually. Sometimes the system or kube control will delete it and that name will be there. Okay. For example, I deleted my deployment and the pods will be deleted by the controller. Okay. So you will find that information. And I will stop here explaining these things. And I want to hand it over to Erica for explaining how you can monitor your application running on your Kubernetes or in other environment. Okay, so let me show you the PPT. Erica, do you want to take over from the PPT?
Thank you. Yeah, I can share. Thank you, Kartik. Thank you. It was a great demo. So what we are going to see now is about another metric that is really important also, that is the span and trace. Okay. So hello everybody, I'm Erika Shunzi, I'm same team Kartik, observability management specialist and system management specialist. So with Kartik we saw and we go through logs and metrics coming from a Kubernetes cluster. What we want to see now is what about span. So once that we are sure that everything is running fine on the customer environment, but what about users? What about end user experience, end-to-end monitoring? Well, having same tool as Kartik show you on the same platform, actually we are able also to have some trace and span generated by the microservices that are running on Kubernetes. So how it happened? I think you already heard about OpenTelemetry, and OpenTelemetry is a standard and is an industry standard actually, and what it consists on make the application generate some trace and some span from each microservices, and the trace and the span are collected in a APM collector, let me say, and at the end you have the end-to-end experience. Trace are our, let me say, business transaction, and span are the single unit. Okay, so when you log and you use the microservices, your session will generate this information that will be collected in a collector, and at the end you will have some data out, and we will see in the second part of this demo. There are several ways that we support span and trace generation. The first one is zip and Jagger, and we will see this with Alberto in 1 minute when he will speak about service mesh. Then there is like APM Java tracer, so you actually add the tracer to your code directly in order to make it generate span and trace whenever you want. And then, of course, if you don't want to touch your code because maybe you are not the owner, because maybe you are not the one who developed it, you can use, we can provide APM Java agent that will instrument the code for you without any modification to the code. So say that, I leave the stage to my colleague Alberto that will show you how to instrument and make service mesh generate code and span and trace, and how we collect into OCI.
Thank you.
So Alberto.
Yeah, thank you for sharing the details about the APM service. I'm Alberto from the application development team, and today we'll talk a little bit more about the service mesh. What is a service mesh? I've seen that many of you say that you've never used a service mesh. So it's better to start with some explanation of why you need a service mesh. And now it can be integrated with all the observability stack and APM. So we will talk about distributed tracing with Istio as a service mesh. But let's start off, what is a service mesh? And a service mesh is a dedicated infrastructure layer that you can add on top of application. It is both a service, a product, and a pattern to create a network of services. And it is also one of the pillars during your cloud native trail map, during your cloud native journey. In fact, if we go into the Cloud Native Computing Foundation and we search for the trail map to become to modernize application, you can see as the fifth pillar, service proxy, discovery, and mesh. So service mesh is actually a pillar for your application modernization journey. So you might ask, why should you use a service mesh? So modern application development is complex. Distributed systems are becoming the norm. So we also need to trace this system and understand these systems. From the developer side, it is difficult to insert new standard features for our microservices, and in some cases, for transactions that spans multiple microservices, it's also difficult to debug the application. And for operators, it is difficult to understand and manage complex operational requirements. So the solution to this is, let's try to simplify it. Let's try to build an abstraction layer where you can insert new features and observe our Kubernetes services. So we live in a world that everything is distributed. Microservices are distributed. And for that, to understand it, we create an overlay network, and this overlay network is the service mesh. And there are many products that implement the service mesh pattern. What we are going to see today is Istio, one of the most used and common service mesh. It was developed by Google and IBM in 2018, and since 2023, so it's very recently, it became a graduated CNCF project. As a matter of architecture, it gets controller agent architecture. So you can see that we have in a control plane and a data plane. The control plane is made up of a pod called IstioD, and IstioD will configure all the other proxies, because the idea of a service mesh is that for every pod, we have also a sidecar container containing an envoy proxy. And this proxy is configured by IstioD. So the ingress traffic will be managed by the envoy proxy, and all the traffic between the Kubernetes cluster and services will be managed by these proxies. To better understand the service mesh and how it works, I created these animations so that it's clear for everyone. Generally speaking, the developer wants to generate a service from a container, let's say with 5 replicas. And then we have our Kubernetes that is divided with control plane and data plane with 3 servers. On one server, we have already installed IstioD. So what Kubernetes will do is take this YAML and create 5 pods. And then we'll try to schedule this pod on the server. So the pods will be scheduled here, and automatically IstioD will add an envoy sidecar proxy. So the same thing will happen to every other pod. So Kubernetes will take care of the scheduling of the pods for the server, and IstioD will inject the Envoy proxy on the pod. And then when everything is completed, we also usually have an ingress controller, in this case, the Istio ingress controller, that is just another Envoy proxies. And this is the point where all the traffic generated by all the traffic enters the Kubernetes cluster. In addition to that, Kubernetes will also make sure that all your pods stay alive, and if a server fails, then the pod will be recreated with the Envoy proxy on it. There is also an Istio add-on for OKE. The LA is open. OKE add-ons are an easy way to install open source software and tools on Kubernetes. So there is this add-on that is being developed, and if you want to try it out and provide feedback, feel free to email the product manager, specify your tenancy ID and region so that you can install Istio in your OKE cluster with one click. But let's see what Istio features are. So by using this Envoy proxy, we can more easily manage traffic, because traffic routing between services is handled by the Envoy proxy, and there are many features for traffic management and security, and that's why service mesh is important, and many companies out there are looking out to implement these service meshes, because it secures traffic between microservices, and it's also easier to implement blue-green deployment, or even injecting fault in microservices to try them out. But since this is an observability focused session, we will focus more on observability for Istio and how you can implement distributed tracing in your application. And we need nowadays distributed tracing because we need to understand the various calls between microservices and also inspect where a faulty microservice can be. So tracing is becoming more and more important in the application development world. But here is the main idea. Let's integrate Istio distributed tracing with Oracle APM. So the idea here is that the Envoy proxy will generate the trace, and this trace will be handled by the Envoy proxies, forwarded to the application, and the application will just need to forward the header containing the span, and so on. And that's how you implement distributed tracing. Let me show you with a quick demo how you can do this. So I'm taking my open lens here with my Kubernetes cluster, OKE cluster. I've installed Istio on it through the Helm chart. And what you need to do to enable distributed tracing in Istio is just to take the Helm chart, and here under the mesh config, we have to configure Zipkin as a backend, but it's not actually Zipkin. It's just because the APM is Zipkin compatible. So the address of the Zipkin backend will be the APM endpoint. And then we also need to enable tracing through. There is I've put a link on the slides on the documentation. So here is the link of the documentation. You can exactly replicate this scenario. So I'm just showing you what the thing that I've done. And another thing that is very important here is the sampling. Sampling is the ratio to how traces have been generated. So the default one for Istio is 1%, but we are telling Istio to generate traces for 50% of all the requests of our traffic, so that we can appreciate them in the APM. To demonstrate this distributed tracing in Istio. I've deployed the book info application, that is the usual application that you deploy when testing Istio. And we can see in the pod here, in the default namespace, I've got all my microservices, and all my microservices have two containers actually. So one is the Istio proxy, and the other one is the actual microservice. So Istio proxy will handle all the traffic for the microservice. And also as an entry point for my Kubernetes cluster, I deployed the Istio ingress controller in the Istio ingress namespace. If we see it, it's just the Istio proxy. So it's just that envoy. And this Istio proxy, this ingress controller, will generate traces for 50% of my traffic and send these traces to the APM. And sampling is very important when tracing, because tracing has an overhead on the whole cluster. And that's why the default one is 1%. So you don't want to have a high value of sampling, because it could impact the performance of the cluster. But just to show it in the demo, I put it to 50%. So I've got my application here. It's just the classic book info application. You can see if I call the product page, the reviews here change, because that's a feature of Istio. So you can manage the traffic through the Envoy proxies and choose different microservices. So by refreshing and making a lot of calls, what will happen is that some of my traffic will be traced and sent to the APM. And if we explore it with Trace Explorer in the application performance monitoring, observability, and management, we can go to Trace Explorer for my APM traces and actually see these traces. So you see this one completed. Some of them have a lower number of spans, because not all requests are the same. Some requests have smaller, they span less microservices, other more. Let's take this one that is quite big. It took also 47 milliseconds to complete. So with this, we have the full overview of the cluster. So we have the Istio ingress gateway. So this is me, unknown client. That's me who just sent the request. It's going to the Istio ingress gateway, and then this microservices is calling the details microservice. So the product page microservice is calling the details microservice, and it's also calling the review microservice. And the review microservice is calling the rating microservice. And we have all the flows here, but just the request and response. So if we take, for example, this one is the details microservice, we have the HTTP URL of the call. So the call that was made and how long it took for the microservice to complete. And this is the information that can help you try to debug microservice application, and also trying to see if there are microservices that takes too much. It is a very, very good starting point for your tracing journey. And it is good, it is a good starting point, because when tracing is active, Istio proxy generates some headers. And then these headers just needs to be forwarded. And this is called tracing context propagation. So all your application, all your microservices have to do is just forward the headers. And that's it. There is no need to modify the code, no need to use any SDK. And it can provide you this much level of detail. But so it's a very, very good starting point, because you don't need to touch the code of your microservices. But then, if you want more details, because you want even your application to trace internal call, for example, to a database, then what I've seen used is integrate this distributed tracing with something like OpenTelemetry, and with OpenTelemetry, you can also send additional spans to the APM. So you can add more details on top of these spans, but you need to modify the code. So you need to use an SDK and configure your microservice application. About this, I'm giving the talk to Erica so that she can show you how a very, very fine-grained span looks, very detailed span looks.
Thank you really much, Alberto. Thank you. So this is the last part, and we will see how to instrument actually a pretty complex environment. Okay. And then we will focus on a specific application to show how to combine with other services. Well, this is the detail that you can get actually out of an application. So an application can be complex as much as you want. You can instrument by agent, by tracing, or even by zipking, everything. And then you can combine in a really simple interface that show how you everything, alert, traces, real user data metrics, and also monitoring, that is synthetic test. So this is that's what you can get, and actually you can go trace. You can get really a lot of details. You can get details on the session, on the users, till the username actually. Okay, that's not not something that we implement, but actually you can have the session and you can mask the username, of course. That's for privacy. And then you can drill down and etc. But let's focus on a specific application now. So let's reduce a little bit the complexity, because I want to show you how you can go deeper and deeper. Actually, what I'm going to show you is this application. So it's made of front end and the back end, and instrumented through a APM Java agent. So it's different. Alberto used zipking. I'm using the Java agent with no any modification of the code. With Java agent is on a persistent volume, a shared file system, and you can use OCI to create the shared file system. And then I put the reference to the Java agent into the services. And I start to produce a span and trace that actually I collect inside OCI in a APM domain. Yeah. Okay. Let's see the result. I'm here. Okay. This is the application. Okay. It's much easier and it's much less populated than the one you saw before. But actually, I still have some data, and I see the front end. I see the back. And I see my services, the satisfaction index, the application server that are providing the services, and the trace. Here I did some navigation, and that has been done manually. Okay, you can instrument also some monitors, of course, so synthetic tests. But let's focus on the traces. Before that, sorry, I want to just say that if you have familiar with OCI, you can go here, and you can see APM. If you go in administrator, actually you can create an APM domain here. This is our collector. And then you can create also an always free domain if you want to have some and run some tests, okay? And you can do even on the free trial, of course. This will be always free. So let's come back on our dashboard, just in case you want to try it out, and we will share with you some link after. And to drill down into traces. So here I have also the database level, okay? I go on the traces, and I see there are some errors, and well, almost all of them succeed, actually. I want to go into details of the trace. And here I can see the duration of the trace. So for example, if it's a performance issue, I can order by duration. and I can drill down. Okay, so for example, in this case, 6 seconds. But let's say that I want to focus more on error, and then I can actually drill down also here, like, I don't know, trees. Okay, so this is telling me which was the code that generated the error, and I can go here, and here from this part I have all the details. Eventually I have also the trace log in case, but here I see that there is like some also drill down. Okay, and then it's really important, this part, because actually it's not just having an APM, okay, but it's having an APM plus a log management plus a monitoring tool all together in the same place. And that allows me to create some correlation. So for example, I saw this, I saw transactional were an error, and then I can drill down into the application dashboard. If I drill down in the application dashboard, for example, what I notice is there is a really high usage of no heap. The heap usage is okay, and here I can also change my my application server. Well, this was the one where they're running that transaction, of course, but eventually I can change, I can do some navigation. So I drill down into metrics, but on the same transaction, I can, for example, drill down into logs, and I'm exactly where we were with Kartik. So I want to understand if I have some evidence on logs also. Okay, and I'm to logging analytics, and from here I have already selected the period of time. I can do even more selection, and here, for example, I see all the logs involved on that period of time where the error happened, and I can use, for example, the clustering functionality to explore the log. So if you have seen, I have like 1,000 of error row or logs row. Then through the clustering, I can reduce, and I can help. I can use logging analytics to actually identify where's the issue, applying the clustering based on the similarity. Okay, so I have some evidence of what could be potential issue, and another thing that is really important, I have the trend. Trend means that where something happen also something else. Okay, that's really powerful if you want to see, for example, error propagation. Let's come back here. I can see how many traces this span affect by drilling down into the tracing session. Okay, it's a really trivial error, this one, but I just generated it. So you have to go to, and actually I can manage my drill down. What does it mean? It means that I can create a drill down, specifying a specific attribute, specifying a URL where I want to end up with, and of course the name. For example, a really powerful drill down is the SQL one. So imagine that you have also the SQL instrumented, so the database instrumented. Well, actually you can really drill down into from your span to the SQL analytics. Okay, so you go here, you go here, you drill down still into trace. And for example, you have all the SQL run by on this period of time. You can see from the duration, for example, this is quite slow. It's affecting 27 span. So I want to, for example, drill down into it. Okay. And this is a statement. So I have the SQL text and everything, SQL ID, sorry, and everything. And what I can do, I can drill down into specific tool for managing database. So that's why we call it observability, because it's not just a monitoring, but actually it's more than this. Okay, allow you really to have a view of the system. And actually, if the out-of-the-box dashboard were not enough, of course, you can create your own one. And this is really powerful because we can enrich what we saw, for example, with Kartik, with our data coming from APM. And so you will have an even more complete view. Well, I will say 360-degree view for your system. Same thing you can do. So with metrics, you can create a widget, you can create and you can correlate widget with logs. And even more, you have a single place where you can actually create alert. So all this tool, as Kartik said, produce metrics. They store the metrics in specific namespace, and the namespace are all managed on a single point in OCI, and from here you can create a specific alert, and this is the single place where you can create alerts, for example. So I want to create, for example, alert on something like, I don't know, span ingestion, for example, or CPU, will be whatever. We have like 1,000 of metrics. And then I also define here a destination that we call topic. And in the topic, can you see we support several protocols. So you can integrate really easily with your taking system or even your monitoring system if you are using one. So that's what you actually can do, and let me remind that you can apply this for, of course, OCI, and it's almost all integrated. You have Terraform script, but also in your Kubernetes on premises eventually, or deployed wherever. Okay, so that. Let me share, and that will be share some document. So we were really fast during this session. We show you the result, and we do focus on the result rather on the implementation. But here you can find all the resources that allow you to implement what you saw today. Okay. So we have a Kartik blog on how to instrument and generate the log from Kubernetes, APM, how to instrument Istio, and how to enable APM on microservices. That's exactly what I show you today. So, Violetta, back to you.
All right. With that, I would like to thank you all for attending this call, and we hope to see you soon again. Bye-bye, and thank you to our speakers today.